Welcome to the deep dive. Okay, imagine needing to perfectly capture, say, a complex factory floor or maybe even a delicate artifact, all in just minutes.
Right.
Today, we're doing a deep dive into the global handheld 3D laser scanner market. It's a field that's, well, it's quietly changing everything about how industries grab real-world data. Super fast, super precise.
Mm-hmm.
So our mission today is to pull out the key insights, maybe some surprising facts for you about this technology.
And it's fascinating because these scanners, they don't just copy things, they create these incredibly detailed digital twins.
Digital twins, right?
Yeah, which are crucial for, simulations, predicting issues, even working together remotely. They basically pull the physical world into the digital with amazing accuracy.
In your hand, essentially.
Exactly, right in your hand. It fundamentally changes how industries think about design, measurement, everything.
That's a really key point. So let's unpack the market growth here because the numbers are, well, they're pretty compelling.
Yeah, they are.
Okay, so the market was worth around, what, $1.5 billion back in 2021?
All right.
But projections, we're looking at $2.17 billion by 2025, and then jumping to a pretty remarkable $4.53 billion by 2033.
Wow.
That's a compound annual growth rate, a CAGR,
Yeah.
of 9.65%. That's strong, steady growth year after year. What's actually driving that kind of acceleration?
Well, it's not random growth, right? It shows this fundamental shift happening. Things like agile development, predictive maintenance, it's becoming standard.
Across the board.
Pretty much. The big driver is just widespread adoption. Think automotive, aerospace, healthcare, manufacturing. All the key sectors are jumping in.
So it's more than just a small improvement.
Oh, definitely. These scanners allow for much faster design changes, non-contact measuring, which is huge, and capturing data on the go. Mobility is a big plus.
Okay.
And looking ahead, these things are only going to get smaller, easier to use, maybe smarter with AI integration. So market penetration is just going to keep growing.
Those numbers are impressive, but where are we seeing the real hotspots globally? Does dominance in one area tell us something about market maturity there?
That's a great question. North America is, well, undeniably the leader right now. Generated $597 million in 2021.
Right.
And projected to hit, I get this, $1.74 billion by 2033. That really reflects a mature market, established demand.
And the U.S. is the bulk of that.
Yeah, the U.S. alone is forecast over $1.33 billion of that. Think quality inspection, automotive prototyping, defense applications. They're big drivers there.
Okay, so North America is strong. What about other regions? Where else is growth significant?
Europe definitely has a solid footing, too. France actually stands out. It's got a CGR over 10%.
Over 10%, wow.
Yeah, which points to their strong focus on digital twin tech and reverse engineering, especially in advanced manufacturing.
And while Europe's strong, you mentioned Asia-Pacific is really heating up.
Absolutely. Asia-Pacific is growing at a really impressive 10.54% CAGR. And within that, you look at India, it's hitting 11.37% CAGR.
What's fueling India's growth?
It seems to be the rise of digital manufacturing, especially in their small and medium-sized businesses, the SMEs. And then you've got Singapore, also strong at 11.09%.
Smart Nation initiatives driving that?
Largely, yeah. Their big push for smart city tech really prioritizes this kind of advanced data capture.
Okay, this is interesting.
But, the real surprise for some might be Africa. It's actually the fastest growing region overall, a stunning 13.66% CAGR.
13.66, that's huge. What's behind that?
Well, it seems less about catching up and more about sort of leapfrogging. They're adopting 3D scanning directly for big new infrastructure projects, managing resources.
So skipping older tech.
Kind of, yeah. It's
Yeah.
making Africa an unexpected leader in digital transformation, particularly in places like South Africa, Nigeria, and South America is climbing fast, too.
Really? How fast?
Projected to more than triple its revenue, from about $102 million in 2021 to $335 million by 2033. Again, digital transformation in automotive construction, it's happening there too.
Okay, so wrapping this up, what does this all mean for you, the listener? I think it's pretty clear from our chat today that these handheld 3D scanners are driving, a global shift. Market penetration is increasing everywhere, on every continent. They're literally scanning the future into existence bit by bit, enabling things that just weren't possible before.
Yeah, and that leads to a final thought, doesn't it? As these tools get even easier to get, simpler to use, and smarter with AI, what completely new possibilities might open up for any industry that needs precise data about the physical world. I mean, how could this fundamentally change how we interact with design, with manufacturing, even with our infrastructure in the years to come? Something to think about.
Okay, imagine for a moment being able to instantly create a perfect digital twin of, well, anything you see,
Hmm.
just by pointing a device. Think about skipping all the complex measuring tapes, the guesswork, getting pure, uh, unadulterated precision, almost like something out of a sci-fi movie, right?
Yeah.
But here's where it gets really impactful. This isn't science fiction anymore.
No, it's not. It's the very tangible reality of handheld 3D laser scanners.
Yeah.
And the market for these devices, well, it isn't just growing, it's uh, gaining rapid momentum. It's really being propelled by a dramatic shift in how different industries approach data capture. We're talking about tools that bring, portability, precision, and speed right where you need it.
Right, portability and precision. And when we start to dive into the applications, your mind might immediately jump to, like, the big industrial players, rapid prototyping in automotive,
Hmm.
or maybe hyper-precise quality control in aerospace.
Yeah,
And yeah, you'd be absolutely right.
sure, standard uses.
But what's truly surprising, I think, is the sheer range of other fields where these scanners are now, well, indispensable.
Hmm.
We're seeing them used for designing custom orthotics and prosthetics,
Yeah.
meticulously restoring historical buildings, like down to the tiniest detail,
Incredible detail.
and even creating flawless digital archives of priceless artifacts before they degrade. It's truly remarkable, the diversity there.
It really is. And what's particularly striking when you look at the sources is how these devices are essentially bridging gaps across fields that, once seemed totally separate. They offer this high-resolution, on-site measurement solution, basically eliminating that cumbersome need to, say, transport something valuable or delicate to a lab. And that capability is proving to be just a critical asset for workflows pretty much across the board.
Okay, so with all this incredible capability, this accelerating adoption, what are we trying to uncover in this deep dive? Our mission really is to navigate the market dynamics, the innovations,
Yeah.
everything that's fueling this powerful tech. We've meticulously gone through all the source material to bring you a shortcut, basically. A shortcut to being well-informed, pulling out the most important nuggets of knowledge, and some surprising facts, too, about these really powerful tools. So let's unpack this.
Okay. Well, the sources point to a few key factors that are really fueling this incredible momentum. Primarily, it's the escalating demand for accurate and, crucially, mobile 3D scanning solutions, particularly in manufacturing and industrial settings. That's a big one. One report even mentioned a manufacturing firm cutting their design iteration cycle, get this, by as much as 40%.
40%, wow.
Yeah, just purely through integrating real-time scan data from these handheld devices.
40%. That's not just like an incremental improvement. That's a complete transformation in efficiency.
Exactly.
And it's not just the heavy-duty industrial stuff, is it? I mean, you touched on this. The sources highlight how these scanners are finding expanding applications in, well, non-industrial areas too. Healthcare, architecture, cultural preservation. What is it about these devices? What makes them so ideal for those maybe more sensitive or less conventional environments?
Well, it's really a combination of things. Their lightweight, portable design is key, obviously, but critically, it's their ability to accurately scan complex geometries and even sensitive surfaces without contact.
Ah, the non-contact part.
Precisely. Imagine trying to measure, say, a crumbling 16th century fresco with a tape measure. It's
Yeah,
just...
impossible. You destroy it.
Right. But a handheld laser scanner can capture its intricate details totally non-invasively, creating a digital record that, might otherwise just be lost to time. So this diversification of use cases, it's a huge driver. It signals a fundamental shift in how professionals capture data in so many fields.
That makes perfect sense. Okay, so beyond the expanding applications, it's clear that technological innovation is also a huge part of this growth story.
Hmm.
We're not just seeing minor tweaks, are we? What kind of next-gen advancements are really pushing the boundaries here?
Oh, definitely not just tweaks. You're right. Sources are revealing innovations like new AI algorithms. These algorithms can actually learn a surface's properties and adjust scanning parameters on the fly,
Wow, automatically.
automatically, reducing manual error by as much as 25%, according to one source.
That's huge for efficiency.
It's a game-changing leap. And we're also seeing vastly improved user interfaces, real-time data processing, all making these handheld scanners just more intuitive, more efficient to use. Plus,
Hmm.
their seamless integration with existing CAD platforms and cloud-based modeling tools, that's really streamlining the entire design-to-production workflow for engineers and product designers.
That is an impressive growth story. But, as with any powerful new tech, there are usually some hurdles, some roadblocks. What are some of the main challenges maybe limiting broader adoption, especially for someone listening who might be thinking about bringing this into their own workflow?
You're absolutely right. It's powerful, but it's not without limitations. One significant restraint we've identified is, frankly, the high initial cost of the more advanced handheld 3D scanners. For a small business or maybe an individual practitioner, that can be a pretty substantial barrier. Are the sources suggesting that this cost is truly hindering adoption, or is the return on investment potentially so rapid that it quickly pays for itself for those who do invest?
That's a critical point.
Yeah.
And yeah, while the ROI can be significant, especially for high-volume users, sources do indicate the upfront investment is still a substantial hurdle for many. And it's not just the sticker price either, is it? Operating these scanners effectively often requires specialized training, which includes everything from calibration techniques to understanding proper scanning angles, and even post-processing knowledge.
Right.
And that training isn't always easily accessible to everyone who might actually want to use these things.
Another limitation lies in their sort of scanning range and environmental adaptability. While they are highly mobile, which is a huge plus, their performance can sometimes be hindered. Think very large surfaces or highly reflective materials or even just variable lighting conditions, especially outdoors.
Okay, so not perfect for everything.
Not always. It means for truly massive projects, like, I don't know, scanning an entire bridge, users might still need to rely on fixed systems or maybe hybrid systems that combine different scanning methods.
And then there's the data itself, right? The sheer volume of it.
Yeah.
These high-resolution point cloud files the scanners generate. I mean, essentially a massive collection of 3D data points defining an object's shape.
Incredibly dense data.
They demand significant computing power, specialized software, vast storage. Managing that, rendering it, analyzing these complex data sets, that can really slow down project timelines, can it?
Yeah,
And add operational costs,
definitely.
especially if a company doesn't have a really robust IT infrastructure already in place.
Yeah.
Are we seeing any solutions emerging for that data management challenge? Maybe cloud-based processing or something?
Indeed. Cloud-based processing is certainly one of them. And despite these challenges, the market is being reshaped by some truly compelling trends. But one standout insight from the sources, I think, is the accelerating integration of these handheld 3D scanners with augmented reality, AR, and mixed reality MR technologies.
Okay, this sounds incredibly futuristic. AR and MR integration. So you're telling me professionals are using these scanners to conduct like virtual inspections
Yes.
or perform immersive design evaluations, maybe overlay 3D scans onto physical environments in real time.
Exactly that.
Can you give us a concrete example? Like, how is this actually being used out there today?
Absolutely. So, one example mentioned in the sources describes construction supervisors using AR glasses. They overlay a 3D scan of, say, a building's proposed plumbing system directly onto the physical framework that's under construction.
Wow, like X-ray vision.
Essentially, yeah,
Huh.
giving them X-ray vision to spot potential conflicts or deviations before the actual construction even begins, or before it goes too far, at least.
Okay, that's huge.
It's a game changer for construction, architecture, engineering.
Mhm.
Anywhere visual communication and collaboration are just absolutely critical.
That's a phenomenal leap forward. And error prevention efficiency, just wow. And another fascinating trend you see driving adoption is the rise of e-commerce and personalized manufacturing. How are these scanners playing a role in that shift towards more bespoke products?
They're truly empowering that bespoke revolution, as you say, as businesses move towards offering more custom-fit products. And this is everything from orthopedic supports and eyewear to bespoke furniture, maybe even jewelry. Handheld scanners allow them to capture precise client dimensions or product contours with incredible ease. Think about getting a perfectly tailored suit, but instead of just measurements, it's digitally scanned for an absolutely exact fit.
Uh-huh. So no more trying to measure a squirming toddler for custom orthotics then. That alone is a win for parents everywhere.
Exactly.
It's fascinating how a tool, maybe originally associated with heavy industrial manufacturing, is now enabling this hyper-personalized consumer goods market and speeding up the time it takes to get these custom products to people.
And what's also notable is the intense focus from the manufacturers themselves on next-generation designs. We're seeing wireless operation becoming more common, AI-powered scanning modes that automate complex tasks.
Making it easier.
Much easier. And increasingly lightweight form factors, too. One source highlighted a scanner weighing under 2 pounds.
Under 2 pounds.
Yeah, but it can still capture sub-millimeter accuracy, which makes it incredibly easy to use, especially on long standing sessions. These kinds of innovations are truly making handheld 3D scanners much more user-friendly.
Yeah, features like automatic object recognition, noise filtering, maybe intelligent lighting adjustments. It really feels like it's expanding the user base, doesn't it?
Mm-hmm.
From those highly trained engineers we talked about earlier to, well, general practitioners, field technicians, maybe even artists or designers. It's making these incredibly powerful tools accessible to so many more people, reducing that barrier to entry we mentioned.
And if we connect all this back to the bigger picture, it seems pretty clear. The market for handheld 3D laser scanners is really poised for robust expansion. It's powered by that continued cross-industry adoption, relentless technological progress, and just that escalating need, really, for accurate, flexible scanning solutions across virtually every sector.
Right. And this isn't just about big industries or specialized fields anymore, is it? Think about the tangible impact for you listening right now. Enhanced user-friendliness through things like AI-powered scanning modes, seamless integration with augmented and mixed reality. These advances are making incredibly sophisticated tools more accessible, more powerful for a much wider range of users.
Definitely.
It's not just for those highly trained engineers anymore. This is
Yeah.
really becoming a tool for, the curious learner, the entrepreneur, the problem solver out there.
Which I think raises a really important question for you to consider. As these incredibly precise digital eyes become more commonplace and even easier to use, what previously complex or maybe even impossible custom creations do you imagine will become achievable for anyone? Whether that's, personalized products tailored perfectly for you, or perhaps preserving a piece of history in ways we never even thought possible before.